Thanks for waiting, and I will start today's tutorial session about the Lex challenge. Thanks for participant today's session, and we are the challenge organizer. And this year, Lex's challenge is related to the music recommendation, but conversational context. So let's start. And before the starting, we are really sorry for the delay of this tutorial because we have some problem in Zoom session. So yeah, thanks for your waiting and patience. And this challenge is organized with six person. So I'm Singando and also Sergio, Bruno, RB Hiva, Claudio, and Francesco is a really big help to organizing this Lexis challenge. And today's content is related to the introducing the task and framework of this challenge. And also we introduce some challenge data set. And also there are several available resources. And we make the baseline system and evaluation system. And so how can we designing the evaluation metrics and also scoring, final scoring things. Sorry, but can you mute your? Yeah, thank you. And another part is the how can we improve this system? So we have several advice, and last part is how to participant and question from you guys. So if you have any question in this Lux challenge, feel free to ask in this Zoom session. Yeah, let's start. Before I start, I will introduce our timeline. So currently we are today's date is May 25. So actually, sir, we are in the blind data set 8 phase. So we already start the readable system, and maybe 1 week later we will start the blind data set B phase, and this blind data set B is a really critical in final readable. So actually the training, development, and blind A data set is just some validation sets. So you can try every submissions with the blind data set A and leaderboard. So you can find the score and overfit on the blind data set A, but we will let it for more generalization ability with the blind data set B. So please stay tuned of some messages. And after the blind data set B phase, this challenge is ended, and we will announce the final leaderboard and winners. And winner need to update your code and also paper. So this if you submit your paper, then we in Lexis conference we will make some workshop about this challenge. So you will be present your paper and your idea in Lexis 2026. And current participant is over 150 participant, 160 participants with the teams. And also they submit more than 3,000. So please keep submit your nice and brave ideas to our the challenge leaderboard site. Yeah, so let's start with our task. So our task is our conversational recommendation system. This system is very similar to the traditional recommendation system or some text to item approaches, but main difference is we more focus on the multi-turn interactions. So what if you, at the first turn, user will ask to the system that they need a fusion jazz with a synth, bass, drum, and saxophone, and maybe your assistant or system can find the relevant music in your database. But this type of the one-shot music search for recommendation is maybe some limitation because our user need a more improvement of recommendation. So in second term, user maybe ask a little bit more groovy songs based on the user's previous query. Then our assistant understand the whole the chat history and recommend the nice music for the users. So In this type of the multi-turn interaction is really important for this task. When we compare with the previous systems, like query by user is a traditional recommendation system, then what if user join the some platform or music streaming service, then we have a user ID. Then our recommendation models, like the matrix factorization model or collaborative factoring model, can measure the dot product between the user embeddings and our item DB, and we can find the most relevant item in our database, right? Uh, and another system is a query by text. So in this system, they can handle the user's text query. So this is very similar with the search bar in the music streaming service. So user enter the natural language query, then our joint embedding model measure the query embedding and item measure the similarity between the query embedding and item embedding, and we can give some recommended items. But our this year's challenge task is our conversational Lexis. So input is a little bit different. Our input can cover the user ID or text query and also chat history. So within the multi-turn context, our system need to understand the very wrong context of users' previous search history in same chat session, and model can find the relevant item, and also they can need to um, generate text response. This text response is a very important role for the user's satisfaction or some usability in your the music streaming service. So that is our main difference between our previous approaches and this year's the challenge task. And let's deep inside of our output of models. So we need two types of outputs. First one is a recommended item. And also second thing is our text response. So uh, if you check our submission format, then we have five different columns. First one is a session ID and user ID, and also ton number, and also we have a predicted track IDs. So our Lexis can predict the most relevant item from uh, users ID or text query and chat history, but also we need to predict the response. So this system need to predict the natural language response for the how can help users music listening the trajectory. So, and this is not a singleton search. This is a multi-ton search. So we need to help to the how can help to user to more focus on the music listening or music recommendation system. Uh, and next part is our data set. So in this challenge, we utilizing the talk play data set. And this data set's main characteristic is this data set containing user profile. So in user profile, there is a unique user ID and also user's age and country and gender. So that is very useful information for recommendation system. And this data set is our conversational data set. So this is a multi-turn conversation with the user's query and recommended music and assistance response. So that is our important characteristic. So there are several important characteristics. So we have our user information and also music item information, including the metadata, lyrics, semantic tag, audio, and album image. Unfortunately, we did not release the audio information and album art and lyrics because we bypassed the copyright issue. So we only released the metadata, only the text modality information. Yeah. And we have the response from the assistant, and also we designed a multi-turn interaction. So that is our main characteristic. And one important message of dataset is this dataset is a synthetic dataset. So this is not a real conversation between human and our uh, some system. This is our LLM generated dataset. So input of dataset is our large scale user listening history data set we call the LFM2B. And they containing user information and session information and users listening history. So that is a really important information, and that is some source and grounding of this data set. And we utilizing LLM wizard of Oz. This is some kind of the role playing with the large language models, and we make some synthetic data set. So we have some input listening history, and we make a profiling track and recommendation track course, and we utilizing two different type of large language model. So we have a listen LLM and Lexis LLM, and these two LLM conversation each other. So, but we give a quite asymmetric information. So listener LLM does not access to the recommendation track first. So they have a limited knowledge and conversation with the Lexis. The Lexis LLM is some kind of a wizard. So they already know every recommendation track first, and they can give some more. They already have a really nice information from the user's listening history. So that is one method for generating quite diverse conversation. And another important information is our listener profile and conversation goal. So actually, we need to make a quite diverse, and we want to cover the diverse user scenario. So we set up the conversation goal for the for condition on this generation process. So conversation goal is related to the conversation topic. So we designing several conversation topic, including the audio and lyrics, sometimes are album art, and sometimes are contextual or uh, some users mood and themes, like music for working or music for studying, something like that. And sometimes the topic is related to interactive refinement. And sometimes the user want to listen music with relate to the metadata. So, and sometimes they want to listen music with the mood and emotion. And some users more focus on the artist, and some users focus on their own culture or geographic characteristics, and social or popularity are important to access. And last part is our temporal information. So we designed the several conversation goal as some condition on generation process. And another the conversation goal is related to query and target specificity. So what if this is some kind of the search mindset. So what if user have a very specific they have a very specific needs and specific target for music, then they maybe ask a system with very specific queries, but sometimes they does not have a very specific ideas. So sometimes they want to play some chill music. Then ground truth is really many types of music, because what if query specificities are very low, then the relationship between query and item is a one-to-many mapping. But what if increase the specificity, then is a more one-to-one mapping query. So we designed the several the specificity. So this one is another condition of generation process. So finally, we release 4 different type of the dataset split. The first one is a training dataset. So we and also we release the. Sorry, but anyone can mute your voice. Thank you. And secondly, we also release the development dataset. One characteristic of the train and development set is we release the ground truth also. So you can measure the every recommendation metrics and also diversity metrics. Yeah. And in case of the blind data set A and B, we does not release ground truth. So blind data set A and B is utilizing for our readerboard, and you can measure the performance via the readerboard only. So that is one characteristic. Yep. And If you want to train your own model, then you can utilize in train and development dataset. And for the final test, we only utilizing blind dataset for the generalization ability. Yeah. So next part. Hmm? Anyone have a question? Maybe not. Okay. Then let's move on to the available resource. So we release conversation dataset, but we also release the track metadata and track vector DB, and also user metadata and user vector DB. So yeah, I will introduce one by one. Firstly, this is our conversation dataset. They have several columns: session ID, session date, user profile, conversation goal, and conversations, and goal assessment. So actually, the session ID is a unique ID of the session, and user IDs are very important because what if you want to utilizing the ranking model, then this user ID information is really critical. And session date and user profile and conversation goal. The user profile and conversation goal is yeah, I already explained. So I will focus on the conversation column and goal assessment. So in the conversations column is our main data set. This is our main data set, and this is a list of dictionary. And within this dictionary, we have our 4 different type of the sub column. The first one is a role. So every conversation containing the user query and recommendation music, and also assistant response. So this role is already always one of 3 role types. And second part is content. The content is actual user query or assistant response or recommended track ID. So that is a content part. And thought is very optional things, but when we generate this data set with a large language model, we also generate some thought. The thought is an intermediate part for the final output. So before they generating the response or query, this synthetic data set already containing the thinking process. So before thinking and give some final output. And also we give some fun number, so we can align the every turns. Yeah. And another column is our goal progress assessment. This is some optional information, and this information is related to the user satisfactions. So during the conversation, sometimes the user does not want to the current recommendation item. So that is the reason why they can move on the next turn. So we designing some user satisfaction columns. So this is our yeah, optional information. I hope this is useful for you guys. Yeah, next column, next data set is our TrackDB. So in TrackDB, we have our unique track IDs. This is a unique identifier of the each music tracks. And we release ISRC is another unique identifier with a global standard. And we release some metadata like a track name, artist name, and album name. And also we'll release the tag list. This tag list is our copy and paste from the LSM2B dataset. So this is our tag annotation from the user. This is a Foxonomy tag, and also the main platform is the Last.fm. So very noisy, but very rich information. Yeah. And we also release some popularity information and release date and duration and artist and album ID information. Yeah. And this is our another available resource is our track vector DB. So we also released the vector database. This is our pre-extracted embedding vector. So we released the audio embedding vectors and album art embedding vectors and collaborative filtering embedding vectors and also text embedding vector. The attribute is our tag list and also lyrics and also metadata. So we extract every music items of the each music items, each modality is embedding vector, and we just released in Hugging Face. Yeah. And in case of the user DB, we have our user IDs and age group, country code, country name, and gender. So yeah. And this user ID is also shared with this conversation data set. So if you guys want to uh, utilizing previous users listening session, then you can filter out this data set with a user ID. That is some way to get see the user's previous session. Yeah. Yeah, and we also released the user vector DB, and this is our user embeddings, and we released the Bayesian personalizing linking model. So this CFBPL is a mapping with the TrackDB's CFBPL. This BPL, TrackDB's BPL vector is a track embedding vector, and this user vector DB's vector is a user embedding vector. So you can dot product between these same columns embedding vector. Yeah. So you can utilizing the linking model. And next part is our baseline system. So our main reference of baseline system is from the Lexis 2020's tutorial on conversation recommendation system. So in the system, the user, there are several subcomponents in conversation recommendation system. The first one is our natural language understanding module, and also dialogue state management module, recommendation engine, explanation engine, and natural language generation module, and also knowledge database. But compared to the 2020, this year is the 2026. So everybody knows a large language model, right? So I think natural language understanding module, natural language generation module, and dialogue management module and explanation module is combined to the large language model. So, so we designed the large language model as a covering quite diverse module, and recommendation module engine is also we can utilizing the text to item and user to item module. So we can utilizing Lexis module, and external knowledge is our user and item DB. So external knowledge is our keep updated. So new users come to our system and new released music is added to the item. So really important thing is our Lexis can handle the changeable external knowledge. So yeah, that is also important things. So we just copy and paste previous Lexis tutorial module in modern design system. Yeah. So let me deep inside of our baseline system. So we have 4 different type of component. The first one is large language model. So main role is generate the natural language response. So that is really important. So we utilizing Llama 1B model, but I hope you guys use more nice large language model because Llama 1B is really bad. So and Lex module we implement 2 different type of the recommendation things. So first one is our BM25 for the text to item, and second part is the BERT model. So these 2 model need main characteristic is that they can measure the similarity, measure the distance between the user query and target item. And also we have our user DB and also item DB. So that is our main characteristic. And our baseline system is our only utilizing text to item module. So that is some limitation of a baseline system. So what if the input data is a query and conversation context, our retriever module, the recommendation system module is a PIM25 and BERT. So they tokenizing everything and they extract the sparse index or global embedding for the input conditions and that product with our item DB. So we can extract the top 20 track IDs and we just select the top one item and that top one item is utilizing for the response generation. That is current system. So our current model is a Llama 1B model. And this 1B model understand the chat history and current recommendation item. They can generate the natural language response. So that is our current baseline system. And next part is our evaluation metrics. So as you see before, our system's input is our user profile and check context. And our conversational recommender recommending the music and the response. And recommendation music is input of Lexis evaluation, and response is our input of the response evaluation. So we can scoring the NDCG and diversity and LLM score and diversity. So let me introduce one by one. The first evaluation metric is the NDCG at 20. So we extract the top 20 recommended item, and this item is an input of the NDCG at 20 measure. So we check the ranking quality of the recommendation tracks. And secondly, we measure the track diversity, actually the catalog diversity. So what if we have some set of evaluation data set and we can collect all the recommended tracks and we measure the set of that track list and we check how many diverse track is recommended with this system. Yeah, that is our category diversity. And second, another part is our lexical diversity. This is not related to the recommendation, it's more related to the response generation. So we want to check how varied the generated language is. So we measure the distinct two. So we measure the bigram and how many diverse bigram is generated from our system. That is our lexical diversity. And last part is LLM judge. We check the quality of the generated response. We utilizing Gemini and some private prompt. We utilizing private prompt, so we can check the personalization and explanation quality. So you just think about the just 2x2 metrics. So we want to measure the quality and diversity in recommendation task and response generation task. So that is our how can we measure and and the weight function is a little bit more focused on the recommendation quality because our 0.5 for the NDCG and 0.1 for the category diversity. So actually the recommendation covered the 60% of the total score. And in case of the response generation, we only give the 0.1 weight for the lexical diversity and 0.3 for the LLM as a judge. Yeah. And LLM as a judge score is a 1 to 5. So we normalize this score to the 0 to 1, utilizing the min-max normalization. Yeah, that is our metric and scoring. And next part is our in case of the LMS judge, we already checked the correlation between the human preference and this type of the LMS judge metric. And compared to the reference-based metric like a blue score, low score, and BERT score or sentence BERT, this LMS as our judge is a quite high correlation with the human preference. So yeah, that is our initial evaluation of LMS judge. That is our end of our evaluation system. And next part is our improved idea. So actually we have some tips for how can improve the ideas. So if you go to our baseline system GitHub repository, there have some tips. So first idea is add the re-ranking model. So currently, we only utilizing the text to item module, but we do not utilizing user to item module. So utilizing user embeddings and also some ranking model embeddings. And if you after this retriever model, you utilizing re-ranker for this type of system, then maybe you can improve your performance. So I hope you guys are utilizing the user embedding and linking model. Yeah. And another part is improve the item representations or some retriever module. So currently, we only utilizing the BM25 and BERT module, but this is super weak. And actually, this BM25 and BERT does not have any ability of modeling the BERT-tongue conversation. So in case of the BERT module, they are utilizing average pooling over the whole the conversation context. So actually, their retriever performance is really bad. So I hope you guys more focus on the advanced text embedding or to some more item embeddings for the more item embedding is maybe very nice approach to improve the system. Especially if you check our conversation goal, then you need to utilizing quite diverse embeddings or diverse Lexis model because our conversation is not only focused on the metadata or text modality. So I hope you guys think about how can you utilizing the multimodal item embeddings for the retriever or recommendation system. Yeah, that is another tips. And another thing is improve your your recommendation system model. So maybe nowadays semantic ID is a quite promising direction. So maybe not only utilizing the text to item model, maybe you can utilizing the semantic retriever model or a more advanced approach is a quite promising direction. So maybe you retrain the another language model with the quantized semantic ID, then maybe you can utilize in a generative way. Yeah. Then these are some tips. And next part is how can participant. So participant is most the easiest thing. So firstly, you join our official Lexis homepage. Our challenge homepage and go down and you can find the register now. So click the register now, then you can find the very simple Google form. So you can write your team name, team track, institution name, and write down the email address. We send the email to you guys, and also you can make a Coda Bench username. So before the register, you go to the Coda Bench, and this is our official readerboard. So if you want to participate, then you can read all the things and just participate this Rexis Coda Bench readerboard. And very nice starting point is you utilizing our baseline system. So baseline and evaluation code is already provided. So especially in the evaluation GitHub repository, we already extract some models inference result. So you can just download the inference result and upload to the Coda Bench. It's nice to starting this challenge. Yeah. Yeah, that is how the participant part. And yeah, these are all the today's material. And do you guys have any question? Then feel free to ask me. Yeah.
Yeah, I have one question. Can I ask?
Yeah. Go ahead.
Yeah, so we tried to experiment with the clap embeddings lately. and we were wondering which type of encoder you used because there are
Ah,
3 or 4 of them. I don't remember exactly, and we couldn't find this information anywhere else.
yeah, I'm sorry for the confusing, and our audio embedding is rely on clock. So I will add this information in our the website. So if you go to the Lion Club, then they have several pre-trained weight. So we utilizing the Lion Club weight of music version. So this weight is our music specific version, and we utilizing this weight for the extracting the Lion Club embedding. So
Okay,
not this.
thank you so much.
And I will,
Okay,
yeah.
thank
One more thing is, I think I have some extracting code, so I will show some uh, extractor audio. Yeah, this is my club embedding extractor code. Yeah, thanks for the question. And anyone have question about this challenge?
Yeah, sorry, I have a question regarding the registration for academic teams. Since we are an academic team, but we did not receive any form or anything to prove that we are actually an academic team, and we were wondering if there were some problems or it's fine like that.
So your question is, you're currently academic teams, but you don't have any the probing material. That is your question?
No, we have proving material, but we did not receive an email or something that like to send it or to ask for proving that we are actually an academic team. Okay.
Your question is how can we prove the academic team? That's your question, right?
Yeah, thank you.
Okay. Actually, we don't have it now because we just collect the every user's participant information. That is only to collect, but I think that is really important because there are some not academic members apply to the academic teams and win the prize. Is there some problem, right? So maybe after the finish this Lex challenge, in case of academic team, we will ask them some photo IDs or some official documentation. Yeah.
Okay, thank you.
Yeah. And I think some member raise on hand. The Priyanka, can you?
Yes.
Yeah.
Hi.
Yeah. Hi.
Yeah. So, yeah. Hi. So my question was like, so in the conversation history, we have a track ID given by the recommender assistant. So can we consider it as a track listening history of a user?
Your question is, how can we get a previous user's listening history? That's your question?
Yes.
Yeah. Currently,
Yes.
actually, we did not release the user's listening history because there are some data set leakage issue. So one one way to I recommend it is just to filter out your training data set. So in the training data set, what if there are several users' previous listening history, but very limited, but you can access users' history with the filter out your training data set with the user ID.
Yeah. So in the conversation, sixth column. So, the role music, we have this content, the track ID. So can we consider it as user history,
Mm-hmm.
listening history of the track.
Mm-hmm.
Can we consider this track ID as a listening history of a user?
Yeah, that's right. Because
This is my
this
question.
data's okay. Thanks for clarification. Yeah, my answer is yes, because every this conversation is grounded and based on the user's listening history. So actually,
Okay.
yeah, thanks for the great question. Yeah.
Okay. Thank you.
I will check the chat session. You already left your question, and actually we considering release the this track history because what if we release the user's previous chat history, then you can retrain your step model or linking model. But we also we worry about the data set leakage issues. So we will keep discuss and uh, yeah, I'm not sure, but maybe we will release the user track, a user's listening history, uh, but maybe not. So I'm not sure. Yeah.
Hi, I'm Sanjay. So
Mhm,
I just have a query. So we have a trained data set, dev data set, and blind data set.
mhm,
Uh,
mhm.
I'm just wondering how will this train actually be used to train? Because oh, even in train we have all these. I think 8 conversations, and in
Mhm,
blind we have 7, and we have to predict the last conversation, I believe.
mhm.
So wondering how can we use this train? This would be like directly. I mean, how can we use this train to? Uh, because we have around 300 or common users between train and dev, but uh, can you shed some light on this? Like, how can this train be useful for us? Uh,
How can your question is how can utilizing trained data set for exact training something? That's your
yeah,
question.
yeah, yeah.
Oh yeah. I think there are several methods because we have two components in our baseline system, right?
Yeah.
So first method is fine tune your large language model. So that's my first answer. So maybe if you're utilizing the tool calling or generative retriever things, then you can fine tune large language model for the Lexis. And another way to utilizing large language model, the training data set is this LLM are more familiar with the recommendation context because our large language model is a general purpose model, so maybe not perfectly fit on the recommendation system. So training data set may be used for the fine-tune LLM. And second part is updating the Rexys. So
Right.
in our data set is our conversational data set. So maybe you can train the another text to item module or user to item module or multimodal recommendation system module. So that is main purpose. Yeah.
Got it. Thanks. That answers.
Yeah.
And just one more follow up. Like you have user goal, which is like moving to
Yeah.
goal. Yeah. Can that be taken as a positive if the recommendation is good, then it's moving towards goal, and if it's not moving away from goal, would mean that the recommendation was not good. Can we take like that?
Actually, not relate to the things. Because uh I think the what if the does not moving toward goal is current recommendation system is not fully satisfied, but partially satisfied the goal. So yeah, that is things. And what if goal assessment is move toward goal is quite move on to the more close to the user's final goal. So yeah, it's some pseudo signal of the user satisfaction. Yeah.
Thank you.
Thank you. And I think another message on the challenge. Could you share this presentation docs? Yeah, I will do that. Yeah.
So,
I think our
one
yeah.
small question. So,
Sorry for the edit. I think the David raised his hand
Yeah, thank you.
earlier. Yeah. Thank you for
Uh,
the waiting edit. So after the David, I directly I answer your question. Yeah.
And we were wondering how many submission we have for a blind B period, because for blind A we have 10 submissions per day, while
Yeah, that is a really good question. Currently, our first idea is only give some maybe the 10 submission for the blind dataset B, but main purpose of the blind dataset B is generalization ability. So we worry about the overfit on the blind dataset B. So we will send an email to the submission number of blind dataset before the start of the blind dataset B. So my answer is not decided yet because we more considering the generalization ability.
okay, thank you.
Yeah, because nowadays we think about the uh, more submission make more overfitting because our current blind data set A readable performance is insanely higher than what I expected. So I think I hope to the blind data set B represented the generalization ability. Yeah.
Okay, thank you.
Thank you. And Edith, can you ask your question?
Yep. Can I ask a
yeah,
question, please?
so my question.
Sorry, or like we have an order, so yeah.
Sorry.
After the edit, I will ask you. Yeah.
Yeah, so my question is that like here you have like move towards, does not move towards, and those hints, right? So essentially, like, are you planning, like, is that for essentially like training an RL system for like
Ah,
fine-tuning LLM? Or like, is that what? So basically, like, when you were designing this problem, what, like, what kind of is like, uh, problem solving capability did you think, like, basically train fine-tuning LLM? Is that what you were thinking, RL thing?
yeah. So, yeah. Thanks for the great question. And firstly, this goal progress assessment is designed for the LL. That is right.
Okay.
Uh, and what we think is this conversation is trajectory for the final music recommendation. So actually, we think about the multi-turn interaction is some trajectory and journey for find relevant music. So this is what we want to design. And we think about the user's query is sometimes not very specified, so very hard to find the relevant music. So that is the reason why we need a multi-turn, right? So yeah, this for a goal progress assessment is related to that trajectory. So we modeling some trajectory design. Yeah.
Got it. And essentially, like, there is like recall and like there is candidate generation and then re-ranking, right? So where does the LLM fine-tuning come into picture in this in both these steps? Can you elaborate?
Sorry, but your question is for the generating the final response, we allow the multi iteration of the model inference. That is your question?
No. Like
Uh, uh,
when you have to like generate candidates, like 20 songs.
mm,
So
mm,
in that, like in your like 47,000 songs, first you
mm,
have to like generate candidates, right? Like let's say 100 songs or 1,000 songs or something like
mm.
that, or 10,000 songs. And then you have to re-rank them, right? Like, and then submit the top 20. right? So that is my basic understanding. So in that, where does the fine tuning of LLM come into picture? And like what step will fine tuning LLM support in that?
Your question is, is it possible to fine tune LLM for the re-ranking?
Exactly. So like, are we doing it for re-ranking or are we doing it for
Mhm.
generating response? Which like for what? So for which task are we doing re-rank? The fine tuning.
Mm. I think the LLM re-ranker is also useful because we already give the every track information in track metadata DB, right? So maybe your large language model understand the very famous music item, then they can they can understand the relationship between the user query and the recommended candidate items. And LLM understand that every natural language and re-rank something is a possible idea. And I remember some of the Lexis paper already study about the LLM re-ranker. So yeah, that is possible idea. And I think a re-ranker is not we can design the quite diverse re-ranker. So we can using the ranking model for the re-ranker, and we can utilizing the multimodal embedding model for the re-ranker, and we can also utilizing LLM as a re-ranker. So yeah, that is our open question, I think. Yeah.
Got it. So essentially, you're saying re-ranker can be multiple ways, but we can use this fine tuning for generating a response. Like, is that
Yeah,
okay?
exactly. So we can fine tune every module. So we can fine tune the LM, we can fine tune the Lexis, and we can fine tune the re-ranker. So that is our everything is possible.
Oh, sure.
Thank you. And next part is maybe Oleg. You have some question.
Yep. So the question is, it seems that there is lots of turns in a trained dataset when the goal track doesn't match the exact user request. I mean, the user requests exact track or group, artist, or genre, and so on, and the golden track doesn't always match it. So I'd like to ask you whether the blind A and blind B datasets have the same, nature of the data when the requested track from user doesn't match the goal track. I mean, there is whether there is any recommender system which gave that golden track for a user or not. Because we can make a perfect match for a user, but this track wouldn't match the golden track in blind dataset. So our recommendation metrics would be low, but the quality of the answer and the quality of recommendation will be high.
Your question is you say about some limitation of current data set, right? So
the question is whether the blind A and B datasets, their nature is the same as the nature of trained dataset. So it's like a subsample. Or not, or the golden tracks are in blind A and B datasets always matches user's preferences.
Actually, yes. The training code is same. So actually, train test blind A, blind B is our same distribution because we utilizing same code and same data set. But in case of the blind data set A and B, we added one more filtering phase. So the last turn of the blind data set A and B is always the golden track. So that means we only utilizing the last turns, the score progress assessment is always positive. So that is one difference between the training test and blind data set. Yeah.
Thank you.
Thank you. I think there is no anyone has a more question about today's session? Okay, great. So then I think we can stop the session in here. So thanks for the participant, and I hope everyone participant in this challenge, and the final readable is based on the blind data set B. So the generalization ability is more important than overfitting. So I hope you guys think about the participant with the generalization ability. That is super important. And yeah. And see you at the Lexis conference. Bye.